Okay, so in this question, we're going to be looking at a given scenario with some information about how a measurement of resistivity can yield information about the properties of blood. So we're told that a medical device can be used by attaching two electrodes to a vein 5 centimeters apart. Okay, so it asks what is the blood resistivity if a 9-volt potential difference causes a 230 microamp current through the blood in the vein. Well, to do this, we're going to start by assuming Ohm's law applies, which is to say that the current through will be proportional to the potential difference and inversely proportional to the resistance. Okay, so I had written this down, and so we also know that the resistance is broken down into the resistivity of the material times the length of the material divided by the area. Okay, so with these tools, we can start to analyze the question. So let's start, since we are ultimately interested in the resistivity, by rewriting this equation in terms of the resistivity. So by doing that, we write the resistance, and then we've got area over the length. Okay, we also know that the resistance is equal to the potential difference divided by the current, and the area and the length. Okay, so now the resistivity is related to quantities that we pretty much all know, except for area, but we can get the area from the given diameter of the vein. So the area is going to be, what's pi r squared, and in this case we're given the diameter, so it's the diameter divided by 2 squared. It's going to give us the area because this is a vein. So right, we're going to have a situation where it's like this. This is our vein, and so we've got this area here, and we're given the diameter, and we're going to look at some length here, and that length is given to us because it says, well, we're going to attach two electrodes 5 centimeters apart. So we're going to do something like, attach one there, and attach one there, and then this length will be 5 centimeters. Okay, so in our case, we've got an area is equal to, well, it's pi. What was the diameter? 1.5 millimeters. Okay, so that's 1.5 millimeters, so times 10 to the negative 3 meters, divided by 2, and squared. So then we have an area that works out to 1.77 times 10 to the negative 6 meters squared. So we've made sure to stay in standard SI units from the millimeters. Okay, I'm just going to keep this a little bit separated out here. Okay, so now we have all of our values, and so we can start to substitute in and make progress towards our goal. So this is 9 volts divided by our current. Okay, so for our current it was 230, and then this is a factor of minus 6 amps. And then we have an area, and the area was 1.77 times 10 to the negative 6 meters squared, and that's all over a length, and the length was 5 centimeters, so 0.05 meters. Okay, and so I'm going to plug all that in, and we get an answer of 1.4, and that is going to be ohm meters. If you look at all the units here, and so our resistance is equal to this term. So one way of capturing the units there is just that will be ohms. So that's here. So that's ohms, and then we have a meter squared over a meter. So we're left with ohm meters. Okay, and that's our answer. I don't know what that tells you about blood, but a specialist would.